Hello, ladies and gentlemen, boys and girls. Welcome to part 3, or what I would call 2B, of this augmented reality tutorial series using processing Unity, mostly free tools. And let's pick it up from where we left it last time. You see over here, this is a processing sketch which we had implemented last time. We shall simply go ahead and run this. So there you go. Hello, I'm your host Anurag Rana, who will be taking you through this series. And in last video, what we had achieved was an overlay of this video stream being taken from my webcam, a PlayStation 3i camera kept across over there, and this 3D cube which is running on top of it. Now, while we have been successful so far, this is not really a true example of augmented reality, because what we really want is we want this cube not to rotate in the center, but let's say follow my hand, and say my hand is somewhere over there and I want this cube to be in my hand. Now my webcam and processing over here will not be able to process my hand yet, although that can be done. However, what we will want it to do is follow this marker in my hand. So can you see the marker? Fair enough. Now, using this marker as an example, I shall take a screenshot and explain to you what will be the theory behind it and how we will proceed on to the next steps. So let me go ahead, stop this, and head on to the new example. Now, if you take a look across over here, you'll remember a bit about the processing sketches. We have an initial void setup program, which basically sets up a display where the various images are displayed, and then it has a draw function. Now let's try to look within this. You see on top, when you instantiate variables, just like you instantiate a variable called I value 0 of the type float, similarly, after you have downloaded and installed the video library, in a similar fashion, what you do is you instantiate a variable called myCam of the type capture. This capture is something which is implemented using the processing.video class. So in the setup function, you say myCam, which is of the type capture. So let's make this a new variable with the values of this, which essentially means running within the sketch of width and height, which in this case is 640 and 480 of this particular screen, of a 30 frames per second, and that results in a webcam capture which every frame when it runs is read from the mycam and is displayed as an image. Now this is the fun where the 3D cube starts happening. After this, what we have over here is a box is drawn, which is this box of size 50. Now this box by default would have displayed somewhere over here in the top origin. However, by translating it to half of the width and height of the window and 25, which is into the plane looking at us, otherwise it would have been clipped by this image, and after that substantially it simply keeps on rotating. Now what we want to do is, in between of all this, we will tell processing that, my dear processing, I want you to start doing computer vision. And how to do that is simply, the way we have all these libraries, we will import one more library. So this entire webcam stream will first of all go to the computer vision library. And what this computer vision library is going to do is, it is going to detect a marker in the webcam stream which is flowing from here with a pattern. Now what is this pattern? This pattern is predefined and loaded into the computer vision library, which should be equal to a specific marker or an image over there, which in this my particular case is this, something which I'm holding. Now if you take a look at it, it's a square piece of paper with a very dark boundary and an image. In this case it is written hero, but the salient features of this image is that, first of all, it is unique, it will be incomparable to its mirror image, and if you rotate it you should be able to check across its rotation. So what this video library is going to do is, first of all, it is simply going to take this entire image, it is going to convert it into what is called as a black and white image, which something I just did, and after that it is taking the entire image and it will convert into just pixels. And imagine that this black and white image simply consisted of just 0 value for the black and 1 value for the white. So this entire webcam image from top to bottom, I'm sorry for that, will be simply divided into its pixel values. And these pixel values will be, for example, here it is white 1, 1, 1, 1. Over here it will be 0, 0, 0. Well, the real pixel grid is much finer than that, than what I'm drawing. So this will be 1, 1, 1. All these values will be 0, 0, 0. Then after that, the computer vision library is going to see where in all these pixels, which is now nothing but a grid of 0, 1, 0, 1, 0, 1, is I'm finding a match in my pattern value, which itself is nothing but a matrix of 0, 0, 1 values, 0, 1, 0, 1, 0, 1, and so on. So my computer vision library will tell me, aha, in this entire big screen, in the top left corner, I have a match. My pixel value 0, 1, 0, 1, 0, 1 matrix over here corresponds exactly with this. And simply what it'll tell you is it'll then pass on this location. Now all you need to do is, you see over here we manually translated our cube. What we want to do is we simply want to add this location just before we declare our box variable, and hence our box now will be drawn where our computer vision library has detected a marker with a predefined pattern. And you're quite right in guessing now that if we are able to implement this, then in our resulting image, our cube will be drawn not in the center, but where we are holding the image. So in order for us to do this, folks, we would need a couple of things, and let me tell you which all things they are. So number one, we need a marker. Number two, we need a pattern file. Now this pattern file is nothing but a matrix of 0, 1, 0, 1 and 0, 1 and so on values, which has been determined by this marker. Third thing is, all these are encapsulated in what will be a computer vision library. In our case, we are going to use NYAR2 library, which stands for NY augmented reality library. And this particular library will also have what is known as a camera calibration. The reason is, most of the cameras, when they capture an image, then it does what is known as distortion, which is straight lines when captured through a camera become like this, and hence it needs to be made back straight using what is known as a calibration data file. So although ideally you should have different calibration data files for all your different cameras, but the library which we will use comes with a predefined camera calibration. It works out of the box, and that is something which we will be using. So let's go ahead and capture these 4 files: a marker file, a pattern file, our computer vision library, and our camera calibration file. Okay, so our next step will be to capture all these and simply add them to our processing environment. Over here, folks, we will switch to our web browser. Now, if you go to Google and simply type NYAR Toolkit, you are going to get the second link, NYAR Toolkit project. And if you check over there, let's simply go ahead and open this. Let's see what we get. Welcome to NYAR Toolkit project. Although the page is in Japanese, but it has an English version available. You can go over there in the library source code NYAR Toolkit library. We have NYAR for processing. Either you can go ahead and download it, and over there you will see how the various markers are over there and being used for different augmented reality projects. However, what I would recommend is, rather than downloading this, please check out the website of this gentleman called CP Botha. So it is available on http://cpbotha.net. Let's simply take a look at that. So here we have a gentleman who has taken the NYAR toolkit library for processing and made a fork of it, which is particularly helpful, and that is the fork which we will use in our library. So although you can take a look at the website, but what we are really interested in some of the files available on his website. So let's simply take a look at some of the files on his website. Over here we should have NYAR for processing multi-marker. Please take a look. It is similar to NYAR toolkit for processing, NYAR toolkit for PSG, similar file, however, a fork of it. So click on this, and over there you should have a couple of libraries. Simply download the library which is the latest, allow it to be downloaded. Should take a couple of seconds. There you go, my download is complete and we have the download NYAR2. If you go ahead and take a look at it, you will see that it is a library with a couple of Java functionalities, and NYAR2, this is the library, computer vision library, which we guys will be using. Go ahead and take a look at in the data folder. You will see camera parameters.dat, which is the data file for the calibration. You will see that it has a couple of markers. For example, you see pathero.pdf, and this is the exact file which we guys will be using. In fact, I've already gone ahead, printed this on a square block of paper, and what I will be using, and a corresponding pat.hero. This is the pattern file which we guys will be using, loading in our computer vision library. You will note that it also has another second marker called pattern kanji, and its according pattern file. Now, although we have gone ahead and downloaded this, what we really need to do this is implement it within our processing environment. So our processing language, typically where it is installed, it'll have a libraries folder. Now if you do not have a libraries folder, simply go ahead and create one. Just call it libraris, and this is where you need to copy the folder which you just downloaded. So I already have this downloaded, so this is where the fun should begin, and we will go ahead and start doing our magic in the processing library. So let's simply save this. I'm going to go ahead, file, save as, and let's call it tutorial processing 3D sketch markers. Now at the same time, let's take a look at a little bit of theory first. So what is happening at the moment is our webcam is going to send us a stream. Somewhere over there we should have our marker, and in order to easy identification of this marker in the overall scene, it has a very distinctive black and white border with a image. Now as this is passed through my web camera and into my computer vision, or which in this case NYAR2 library, which already has a preloaded pattern, it simply compares the pixel values, a matrix of 0 1 0 1 0 1 and 0 1, and says that this is in the top left approximate location. However, that is just translation. Another important variable is if this pattern is found what is called squish or squashing. In this particular case, our library will also try to guess what is its orientation. In this particular case, it's the Z orientation which is always pointing up, and the processing library might say, hey, it seems that your pattern has rotated by, let's say, 10 degrees on its x-axis. So all this information is passed as a translation, and once we draw our box or our cube after this translation, it will simply appear as if our box or cube is hovering over this pattern. So let's go ahead and start implementing these features. Back to our processing environment. So we would start out by first of all importing our new library. So it has added import jp.nyatla.nyar for processing. So far so good. We need to instantiate this variable just like we had instantiated our capture and mycam variable. So this variable will be of the type nyar multi board nya. Void setup my cam. Over here we should instantiate this as well, and we should say ny, the variable we just declared, is going to be a new of the type nyarmulti board, and certain set of arguments. Now what are the arguments which it takes? First of all, this. Second is once again width, height, camera underscore para dot dat. This is the pattern, I'm sorry, not the pattern file, but the camera calibration file, and after that it needs an array of types pattern and of widths. What are these two arrays? First of all, pats is an array, I'm sorry, string type array. Let's call it pats. This is something which we will use over here, and let's put a value over here which is going to be pat.hero. Now if you see, pat.hero and camera para.dat are two files which we had downloaded, and these two files, how does processing know where these files are? So this is going to be quite quick. You go to your data, camera para.dat, pat.hero, simply drag and drop over here. Hold on. And now if you go into sketch and if you say show sketch folder, oops, sorry, did not seems to have happened. Now when we copied this over here, it says two files added to the sketch. Let's go and see show sketch folder, and we have data, and these two files have been added across over here. So far so good. Now let's head back to our sketch. We have already created an array called patterns where we have listed at least one pat.hero. The reason is we could go ahead and add many patterns because this is a multi-marker library. However, at this time we are going to content ourselves with only one pattern. This pats array is passed on to the declaration of our variable, and you see it has a secondary array which is called widths, where let us just declare this array as well, widths, and enter a value 80. Now what this means is that we are telling our new nya marker that listen, please instantiate this new variable in this library with the width and height allocated, include the camera parameter data file, a patterns array which consists as of now only a single pattern by the name pat.hero, and the widths of all these arrays which we have mentioned over there is going to be approximately 18 mm. Let's see if we run our sketch and if this results in an error. Well, no error so far, so far so good. So what next? What we are going to do is we need to check that is this marker even being checked by our computer vision library which we included, and the easiest way to do is include our 3D cube in an if value. But what will this if value contain? What will be the if statement? Simply check the new variable which we said, is it detecting the pattern, but detecting it where? In this mycam image which is being generated every frame from our webcam. Okay, so what do you think should happen now? Let's take a look. Aha, so we have the image but there is no cube. Now let me pick up my marker and show it over there. Wow, something is happening. If I show the marker, image comes. If I don't show it, no cube. Now what this means is definitely our marker is getting detected. So far so good. However, what we want is we want our this particular cube to sit over here. And that is going to be step 2, ladies and gentlemen. Now, over here, we have a translate and a rotate value. What we want to do is we want the translation to come based upon this detection of this marker. Okay, so let's keep the box, but what we are going to do is pick up the translation and rotation based upon this detection. So let's add this code nya.markers. Now, like I said, it is a multi-marker library and it takes a pattern array. So there could be multiple markers, but in our case, we have given only a single marker. So we should say nya.markers0, which means the first marker of the array, which is pattern.hero dot begin transform. What should that lead to now? What it means is, and let's just copy paste this, in transform. Now what this is going to result in, if within my cam image being taken every frame from the webcam, nya detects any of the markers, which in this case is a single marker, then it is going to pick up the transform of that image and should make a box over there. Should this work? Absolutely it should. Let's take a look. What do we have? Are we ready for this, ladies and gentlemen? Aha! Congratulations! The cube is now not just anywhere, but it is following the marker in my hand. Ladies and gentlemen, congratulations, you just realized augmented reality. However, there is a little flaw over here. You see, it does not really seem to be sitting on top of my marker. Now, what's the problem? Here's the thing. When the library detects it, it identifies its center point 0, 0 over here, and if this is the cube, it draws the cube right at the center, but that's not the case. We want this cube to be sitting on top of it. Okay, so just allow me a moment over here. You see, the box has a dimension of about 50 pixels. So if you do translate this box 0, 0 by half of this height, then it should pop out and sit right on top of the marker rather than being displayed in right center. Let's quickly run this. Once again, we are back. Let's show the marker. There you go. Ladies and gentlemen, congratulations. You have successfully achieved augmented reality where a pattern is detecting a marker in the image and drawing a cube on top of it. However, there are certain limitations. First of all, we have not gone too much in depth of processing. So although I have simply taken you through a couple of variables over there, for example, how to instantiate this variable, how to detect it, and how to end and begin the transform, there is an entire set of things what you can do with this particular library, and all of them you will be able to find in the downloaded libraries folder. It has an index, it tells you about all the variables, but like I said earlier, our aim is not to get into the depths of processing of this library, but to understand the theory behind it and then start using it in a program which is much more advanced and does not have the limitations. For example, one of the limitations is if you take it too back, you will see it'll start to disappear. The reason is, if you call this screen to be 0, 0, if I call my screen to be 0, 0, where this is being displayed, at 0 location my webcam images, and when this goes behind, the webcam image precedes and my marker or the cube being drawn in this particular case simply gets clipped. So it is only made if the z value is ahead or positive compared to my webcam image. And second is, well, who is interested in simply drawing a cube? What we want, for example, like the axe image is like an angel or maybe a jet or a rocket taking off or a car or a mobile phone or a helicopter. However, processing is not the best environment for us to handle so complicated 3D graphics where you have beautiful shadows and lighting and animation, and this is exactly where Unity 3D is going to come in. So gentlemen and ladies, boys and girls, congratulations so far for coming up ahead till this location, and in our next video we are going to implement the same functionality, marker tracking, but with far better 3D objects in a far better program called Unity 3D. So thank you very much for being kind audience. I hope you learned a couple of things, and please feel free to contact me on my website www.anuragrana.com/about, and hope you enjoyed it so far. Thank you very much.